Let us look into this interesting questions. During nuclear explosion, one of the products is strontium with a half-life of 28.1 year. If 1 microgram of strontium was absorbed in the bones of a newly born baby instead of calcium, how much of it will remain after 10 years and after 60 years if it is not lost metabolically? நியூக்ளியர் எக்ஸ்ப்ளோஷன் நடக்கிறப்ப வரக்கூடிய ப்ராடக்ட்ஸில் ஒன் ஆஃப் த ப்ராடக்ட் வந்து ஸ்ட்ரான்டியம். அதோட ஹாஃப் லைஃப் வந்து 28.1 இயர்ஸ். இப்போ புதுசாக பிறக்கிற ஒரு பேபியோட போன்ஸில் கால்சியத்துக்கு பதிலாக 1 மைக்ரோகிராம் ஆஃப் ஸ்ட்ரான்டியம் அப்சார்வ் ஆனிச்சுன்னா 10 வருஷம் கழிச்சு அது எவ்வளோ ரிமைன் பண்ணியிருக்கும், எவ்வளோ பாக்கி இருக்கும். அப்புறம் மெட்டபாலிக்கலாக அது வந்து டிக்ரீஸ் ஆகலைன்னா 60 years கழிச்சு எவ்வளோ பாக்கி இருக்கும், இதுதான் கொஸ்டின். ஸோ ஆஸ் வி நோ தட் இது வந்து ரேடியோ ஆக்டிவ் டிரான்ஸ்ஃபர்மேஷன், ரேடியோ ஆக்டிவ் ரியாக்ஷன் அப்படின்றதுனால இட் இஸ் அ ஃபர்ஸ்ட் ஆர்டர் ரியாக்ஷன். அதில் நமக்கு சந்தேகமே இல்லை. ஸோ ஆல் ரேடியோ ஆக்டிவ் டிரான்ஸ்ஃபர்மேஷன்ஸ் ஆர் ஃபர்ஸ்ட் ஆர்டர் ரியாக்ஷன்ஸ் நம்ம படிச்சிருக்கிறோம். ஸோ திஸ் இஸ் அ ஃபர்ஸ்ட் ஆர்டர் ரியாக்ஷன். ஸோ லெட் us write the equation for first order. That is K that is equal to 2.303 by T log of R naught by R. That is initial concentration by final concentration. Right? Initial concentration by final concentration. So what we have to find out here, இப்போ நமக்கு என்ன கண்டுபிடிக்கணும்னா 10 வருஷம் கழிச்சு ஆஃப்டர் 10 years எவ்வளோ இருக்கும், அண்ட் தென் 60 years கழிச்சு எவ்வளோ இருக்குன்றதை நம்ம பார்க்கணும். So let us write the data is given. So என்ன data கொடுத்துருக்காங்க, T of that is equal to 28.1 year. 28.1 years கொடுத்துருக்காங்க. So what is the formula for T of first order reaction? T of that is equal to 0.693 by K. So this is the formula for calculating first order reaction. அப்போ நமக்கு டி ஆஃப் கொடுத்துட்டாங்க. டி ஆஃப்லேருந்து நம்ம ரேட் கான்ஸ்டன்ட் கண்டுபிடிச்சோம். ஸோ கே இஸ் ஈக்குவல் டு 0.693 by 28.1, right, per year. So this is a K value. So here in this equation can be written as KT by 2.303, KT by 2.303, that is equal to log of A by B, that is equal to log of A minus log of, that is log of R naught, initial concentration, minus log of final concentration, right? Okay. So this can be written as, what is the value of K here? 0.693 by 281. Let us substitute here. It is 0.693 by 281. This is the value of K into time. First, what is this? 10 years, right? 10 years. So T by 2.303, that is equal to log of R naught. What is the R naught initial value? Initial amount is 1 gram, right? Final amount is, we have to find out the final amount. That is log of initial amount 1 microgram minus log of R. This is what we have to find. Okay, so we can work it out. So let us write that log of 1 is nothing but 0. So let me write like log of R, that is equal to concentration R, that is equal to minus of 0.693 by 281 into 10 by 2.303, right? That is equal to, this value is equal to minus of 0.693 1070, 0.1070. Yes. So log of R is equal to 0.1070. Let us write in the next slide. That is, let us continue here. We have to find out log of R is equal to concentration. Log of R is equal to log of R is equal to minus of 0.1070, right? So then, so log if it is goes there, the concentration of R, that is equal to anti-log of minus 0.1070, right? Anti-log of minus 0.1070. So this can be written as anti-log of minus 0.1070 plus 1 minus 1, right? So this will be anti-log of 1 minus 0.1070, that is this part, 1 minus 0.1070, that is equal to 0.893 into 10 to the power of minus 1 into 10 to the power of minus 1. So if you take the value, the concentration, if you take the anti-log value, the value will be 0.7816, right? The unit given is micron grams. So whatever the unit given there, you have to use the unit at last, right? This is a concentration of R, right? Let us come from the beginning. So listen here, all the radioactive reactions or first order reactions, so that we can written the first order equation, K is equal to 2.303 by T log of R by R. Here other values have been given. It is T half value they had given. T half of strontium is 28.1 is. From this one, we had calculated the rate constant value. K is equal to 0.693 by T of, that is 28.1, right? We are substituting in this equation. Now, in this equation, we got the rate constant value, we got the time, we got the initial concentration, and we have to calculate the concentration of the R, right? At the time period of 10 years, right? So we had substituted and we had arrived at the value. Let us go for 60 years, if not. The same concept, we have to go for 60 years. So where we are going to make a change, let me make a little change here. Like listen here. So here, where is the change here? Instead of 10 here, instead of this 10, I'm going to write 60 here. Remaining all will be okay. And here, instead of initial thing is 1, yeah, remaining all will be okay here. So if I change this as 60, if I change this as 60, so the value will be log of R is equal to here. Let me work it out for you one more time. Let me work it. Let me write the equation. That is K is equal to 2.303 by T log of initial concentration by final concentration, right? We had given T of is equal to 0.693 by K. So K is equal to 0.693 by T of straight away, right? 28.1, right, per year. Substitute this in this equation. That is, here this equation can be written as 0.693 by 28.1. This is the value of K into, what is the time period? Time period is 60 years. Yes, 60 by 2.303. 60 by 2.303, that is equal to log of initial concentration is 1 gram minus log of R. So we can write log of R concentration part. Concentration of R, that is equal to this entire part will become minus 41.58 divided by 64.71, which is equal to minus of 0.6425, right? That is log of R is equal to 6.25. Then we can write concentration of R is equal to anti-log of minus 0.6425. So this can be written as anti-log of minus 0.6425 plus 1 minus 1, right? So this is equal to anti-log of, so 1 minus 0.6425, 1 minus 0.6425, that is equal to 0.3575 into 10 to the power of minus 1. So if you take anti-log, let me continue here. So the concentration of R, the thing is, concentration of R is equal to 2.278 into 10 to the power of minus 1, right? So this can be written as 0.2278 unit is micrograms. This is a concentration of R at 60, after 60 years, right? After 60 years. Got it? And here, this is the concentration of R after 10 years. This is a concentration of R after 10 years.